Hi, so in this video is a follow-up to a follow-up video that is going to now allow us to write proof on our own without filling the blanks. So you will need a separate sheet of paper, so go ahead and I'll take a minute while you get that out. And now what we're going to do is we are going to have to fill in our own logic. Now, some of you might see objects different in these different triangles, so there might be different ways to prove them congruent, and that's okay if you do that as long as it's mathematically correct and you justify your steps. So the one way that I'm doing it might not be the only way, and that's okay. So check with your teacher or check with a peer so to make sure that your logic is still sound. So I'm going to start it off like I did all my other fill-in-the-blank proofs, and the way I'm going to start it off is by marking the picture. So AB is parallel to CD. AB is also congruent with CD, and so I'm going to mark my side. Again, taking that inventory. Now, when we do that, folks, we want to go ahead and start each proof with our given. And then, of course, we want to state that it's given. So then I want to look at the picture and figure out what else do I know. Well, I also know that AEB is congruent to CED because of the vertical angle theorem. Vertical angles give us congruent angles. And so I'm going to write that. CED is congruent to angle AEB by the vertical angle theorem. So again, I'm going to look and see I have a side here. I just stated an angle, and so these can't be fleshed out anymore into further branches. But I don't have enough to prove triangles congruence. And so I want to look and try to figure out what else can be fleshed out and what else do I need. So I notice parallel most likely are going to give me some kind of congruent angles. And if I actually have another angle, I can prove the triangle is congruent by angle, angle, side. So I need another angle. So looking here, I have these parallel lines. And notice, cut by a transversal, B would be congruent to D by alternate interior angles. So I can go ahead and say that angle B is congruent to angle D because parallel lines cut by a transversal give us congruent alternate interior angles. And there is my last angle pair. Now, a lot of you might say, well, we don't need the vertical angles. We could also say A and C are congruent. And if you do that, then you could say angle, side, angle. And you're exactly right. But since we already have all of the pieces that we need to prove triangles congruent, we don't need to state anything else because it would just be irrelevant information. And so by angle, side, angle congruency, I can say that triangle AEB is congruent to triangle CED. And you want to be very careful when we are naming triangles because you want to make sure that the corresponding letters match up to the corresponding parts of the triangle. So then I go and double check and look at what I'm trying to prove. Well, I'm trying to prove that segment AE is congruent to segment CE. So from congruent triangles, I can say that. And I can say that because corresponding parts of congruent triangles are congruent, or CPCTC. And so once I prove the triangle is congruent, I can then say corresponding parts of those congruent triangles are congruent, and so then I can finish with my proof. And that's how we're going to build our own proof. So now let's look at a couple more examples. Again, start with marking up the picture. Segment IG bisects angle FI, and we want to make this correction that it's FIH. So it bisects FIH, which means an angle bisector gives us congruent angles. So I know that these two angles here are going to be congruent to themselves. So let me go ahead and state my given. And I also have IF is congruent to segment IH. So then I would need to look and see what else I know. So again, make sure we're taking inventory. We have our sides, we have our angles. I also know that IG is congruent to itself by the reflexive property of congruence. And so there is my last angle or side pair that I need for side, angle, side. So now let's look and see what we need to flesh out. So I have my side here in my proof, and I have that IG bisects the angle. Well, I need to go from angle bisector because an angle bisector gives us congruent angles because of the definition of an angle bisector. And so then I'm going to state that angle FIG is congruent to angle HIG. And once I do that, I now have the last piece I need for congruence. By side angle side, I can prove the triangle is congruent. And so I'm going to go ahead and say that triangle FIG is congruent to triangle HIG. And then I double check the proof. Well, I'm trying to prove that angle F is congruent to angle H. And again, from congruent triangles, I can say that angle F is congruent to angle H because corresponding parts in congruent triangles are congruent. And I have my proof. So the last example we're going to look at is a little trickier, but I have all the faith that you're able to do it. Let's mark up our picture. Segment KL is parallel to segment JM. Segment KJ is parallel to segment LM. Now notice I have parallel lines. Well, we know parallel lines are going to give us some kind of congruent angles, so let's look for those congruent angles. If we look here, these parallel lines, again, in a previous video we talked about parallel lines have to be a part of the angle, so they have to form the angle with the transversal. And so this parallel line with the transversal says, oh, well, it's angle LKM, which would be congruent to this angle formed by the transversal in the parallel line, JMK. Well, then I have these other set of parallel lines, and so it might help to turn our paper so that we can see these parallel lines cut by a transversal and see that angle LMK is going to be congruent to angle JKM because they are alternate interior angles. And so now let's write that in our proof. So we start with our given. Segment KL is not congruent, which is a common mistake, but parallel. So parallel does not give us congruent, so you want to make sure that you're really being careful when you write it. And that's our given information. Segment KJ is also parallel to LM, which is given. And then if we look, we see a shared side, KM. And we know KM is congruent to KM by the reflexive property of congruence. And so this reflexive property of congruence gives me a side. And so I have a side, taking inventory. The parallel lines, we showed that for KL, for the KL and JM parallel line pair, that angle LKM was congruent to angle JMK. And then we said, so there's another angle, and then we said that based on KJ and LM parallel pair here, that the angle MK is congruent to angle JKM. And both of the reasoning is because parallel lines cut by a transversal give me congruent, alternate, interior angles. And so notice I have a side and I have my angles, and based on the placement, the sides are in the middle of the angles. And so it's an included side. And so then I would say by angle side angle congruency, triangle JKM is congruent to triangle LMK. And again, it's very important that we are naming the triangles for make sure that the letters correspond. So once we have that, double check the proof. And here the proof is that KJ is congruent to LM. And we can say that because KJ and ML correspond. And the triangle is congruent. So corresponding parts of the congruent triangles are congruent. And so again, we're building our own logic by marking up the picture, taking inventory, and making sure we have all the pieces we need to prove triangles congruent.